Hey there, welcome to Linear Equations and Rational Equations. This will be the first class in a scope of college algebra. This will be a little bit of review, a little bit of new stuff. Hopefully it's not too complicated though, and hopefully you kind of get a grasp for it after watching this video. There's not a lot to go over, really just two main topics, but we'll see as we go on they get a little bit harder. But if you watch this video and you do your homework, and you study and learn on your own at home, whether that's through the book, through YouTube videos, through Khan Academy, whatever you want to use to try to learn these topics, you're going to do just fine. And you're going to see that college algebra isn't that bad. So before we get started, classroom creed, just like in class. Before we say the classroom creed, it is cool to say the creed. You know what's not cool? Failing college algebra. You know what happens 100% of the time? Kid sits in class, doesn't say the creed, guess what happens? Fails college algebra. You know what else happens? Kid says the creed, he learns college algebra. It's that easy. So, we're going to get started with this creed. Today is a new day. I can read and remember well. I can develop my viewpoint and apply it correctly. I have eyes to see, ears to hear, and a mind to understand. It might not be easy, but it's worth it. All right, let's get started. Linear equations and rational equations. I'm going to shrink this down real quick so you can't see me, but you can see the screen. Boop. There we go. All right, so what is a linear equation? What is a rational equation? Why do we have to learn both of them? Well, obviously, if we're thinking about linear equations, we think about the key word in there, which is line, that huge key word right there. Anytime you see a line, you've got a linear equation. And then what's a rational equation? Well, there's a key word there too, right? Ratio. What's a ratio? That's just another word for fraction, which is what you've seen. I know nobody likes fractions, but you've seen them a bunch of times. So anytime you see a line equation or the equation of a line, y equals mx plus b, think linear. Anytime you see a rational equation, think fractiony, okay? More specifically, it's going to have an x on the bottom, but we'll see that when we get there. So line, fraction. Cool? Cool. So a linear equation in one variable, we're not doing two variables yet, we're not doing a billion variables like calculus or something further, is an equation that can be written in this form. Ax plus b equals 0, where 0 is some number and a is not 0. Got a little side note there that a and b are also real numbers. We'll get to that later on in the year when we talk about the opposite of a real number. If you do know what a non-real number is, that's awesome. You're already ahead. So let's get started with this example one real quick. This should be review. I'm hoping this is review. Anytime you see this equal sign, what do? You draw a line, right? Now, if you can do it without the line, by all means, go for it. But I told my students all the time when I was teaching high school, draw the line. Don't forget to draw the line, because what you do to one side of the line, you got to do to the other side of the line. So what's our goal in all of this? Our goal is to get x by itself, whether it's the simplest problem like this one or a super long and difficult problem like we might see later. Our goal is always the same, get x by itself. So what's keeping x from being by itself? I don't know. I see a 2, I see a positive 3, I see a 7, but the 7's kind of doing all right over there. So we got to ask ourselves, well, which one's the easiest to get rid of? Or which one's the least complex thing that's happening to the x? Probably the plus 3, right? What's the opposite of a plus 3? A minus 3. Hopefully you've seen this before. Looks all like this. What's 3 minus 3? Cancels out, right? Because 3 minus 3 is 0. So we're left with just 2x on the left, and 7 minus 3 gives us 4 on the right. Now you got to think about, oh, there's an invisible sign here. There's only one thing that gets an invisible sign ever. There's only one invisible sign in all the math. There's no more invisible signs. You'll see every sign except for this one. So anytime you see it, if you want to, if your brain wants to say, hey, I hate those invisible signs, I forget about them all the time, zoom in real big and put a dot right there. You know that dot stands for multiplication. The only invisible sign ever is always multiplication. So, got that multiplication there. What's the opposite of multiplication? Division. Get x by itself. We're going to divide by 2. What you do to one side of that red line, you got to do to the other side. 2 divided by 2, it doesn't actually cancel out. It turns into 1, right? Because 2 over 2 is 1. But a lot of times we like to say it cancels out. But it's actually in your brain, don't forget, it's turning into 1. It's not necessarily canceling out. Because if it was canceling out, maybe it would take the x with it. But it's not. It's turning into 1, and 1 times x is x. So x equals 2. Groovy. Not too crazy, right? Hopefully. If that was all college algebra, you'd be like, woo, we're done. Yay, that's easy. It's more like regular algebra. We're not going to do the second example. I'm going to leave you to do that on your own. But you know what we are going to do? That's right. Check it. We're going to check all our work. So let's look at this, and we're going to say, where do we take that x and plug it in or substitute it in. We're going to take that x, that value we just solved for x, and check our work by subbing it in. I'm going to do this in blue. I don't know why. Check it in blue. 2 times, instead of writing the x, what am I going to write? Ooh, I should make a time sign instead of that so it looks the same. You could put the parenthesis. That's what I usually do, so I remember to put everything in there. But if you want to just do a time sign, that's okay too. 2 times. Now what goes there instead of the x? Obviously a 2, right? Boom. Plus 3. Now we're not going to write the other side because you know what we're doing? We're checking it. We're seeing if it's true. So we're not going to write the other side. We're just going to look at this side and see what happens. Well, what do we do first? Here's a good time to review. I know this video is going to be a lot of review as we get started this year. Lots of review. Order of operations. You've probably seen it as Pemdas. If you don't know what that means, come talk to me. Come send me a message and I can post another video about Pemdas if we need it. Send me an email. My email's all on my website. If you're struggling with PEMDAS or the order of operations, feel free to let me know. But basically what that says, I'm not going to write them out for time, but we've got parentheses that we do first, exponents that we do second, then multiplication and division are on that same line, and then we've got addition and subtraction that we do last. Cool? So what do you see first? Parentheses? Nope, no parentheses. Exponents? Nope, no exponents. Multiplication and division? I see multiplication. What's 2 times 2? 4 plus 3? 7. Does it check out? Does 7 equal 7? Yes, it does. Our check worked. All right, so that's really important. I know you could have done that in 3 seconds and I took 3 minutes. But what's really, really important about that is that you see the process and the steps that you take to do it. I don't care about the right answer. We'll talk about this in class. I could care less about the right answer. You could give me 100 right answers and not know how to do it, right? But if you know how to do it and you know the steps with the easy ones, then you can use those steps on the harder ones. But if you don't know how to do it, you don't know how to do it. You're never going to get it. So I know you got photo math. I know you got Wolfram Alpha. I know you got all those things to do all the work for you. But if you don't know how to do it, you don't know how to do it. And that's what we're trying to fix. We're not trying to get the right answer. I could care less about the right answer. I care about you getting the knowledge in your brain. All right, so solving a linear equation. We kind of just solved a super easy one that should have been a review. But what happens when it gets a little more complex? I'm not going to read all those words to you. You know how to read. I hope you know how to read. But I am going to do a quick little breakdown that I like to say before I get started on this. It's this D, C, M, A, M. It's not that crazy. Some people are like, don't call me after midnight. Or someone's like, actually, that's the only one I know. Something about moms or something. I don't remember. But what that stands for is the steps to solve a single equation variable. These are steps to solve. What do you think the D stands for? Distribute. Distributive property, that's like a 3rd grade thing. That's really hard for a lot of people, but it's not that hard, and we're going to break it down so you know how to do it. Then what C stand for? Combine like terms. If you don't know what a like term is, then we got to learn what like terms are before we can combine them, right? So we're going to talk about that. Then we're going to move all x's to one side and numbers to the other side. Okay? Not too crazy. We're just going to move the stuff around. Then the A stands for add or subtract whole numbers. And that's what we just did. Once we get to these green lines that I'm writing right now, that's what we just did in that first problem. And then M stands for multiply or divide the coefficient, which we also did. The add, subtract the whole numbers, that was right before where we added or subtracted 3. And multiplying or dividing the whole numbers was when we divided that 2 to get the x by itself. So that's a shorthand version of what the book gives us for solving a linear equation. They're both good. They're both the same exact thing. They just use a lot more words. So let's watch this and see what happens. Example 2. Distribute. Distribute has to see parentheses. If you see parentheses, chances are you're going to distribute. So we're going to take that 2, and it's just like if I brought cookies to class and I had to give a cookie to everybody, and then one person in the back saying, you didn't give me a cookie. Well, that'd be bad, right? So I got to give that 2 or that cookie to every single thing inside the parentheses. So we give the 2 to the x, and we give the 2 to the negative 3, and we're left with 2x minus 6. Everybody okay with that? I got rid of the parentheses, and I multiplied the 2 times the x to get 2x, and the 2 times the minus 3 to get minus 6. Minus 17. Ooh, I forgot to do step 1, which is draw that red line. That's bad. I won't forget next time, I promise. That's terrible. If I'm doing that in class and I forget to draw that line, you yell at me. You say, hey, draw the red line. And I'll be like, here's extra credit or a piece of candy or something. All right, then we got to distribute again. Take that. Ooh, here's a good example. I'm glad this is here. We're going to take the sign with it. That's a whole negative sign we're bringing over there. We're bringing the sign. I'm going to underline it so you can see that, so you know where I'm getting it from. And we're left with 13. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. Cool. All right, that's the distribute. No more parentheses. You can't distribute. Now it's combining like terms. And we're going to do this step on either side, the left side and the right side separately. So what we're going to do is we're going to look at this left side and say, does anything look the same? Now here's a good note for your brain. Like terms doesn't mean, oh, they both have 6s. Like terms mean they have the same variable, x, and the same exponent. In this case, there's no exponents. So same variable, same exponent, like term. Not same variable, not exponent, you can't combine them. So here we're going to combine the two things that look alike. So this and this look alike, right? The 6 and the 17. You know, don't look like it? This 2x. It looks weird, right? So what's negative 6 minus 17? Ooh, here's some brain math. Negative 23? If I'm wrong, tell me. So we're left with 2x minus 23. I'm going to mess up math like that all the time. And if you're in class and I mess up that math, you just yell at me and be like, that's 24. I'm like, oh, yeah, you're right, it is. So negative 6 minus 17, 23. And then what looks alike in the other side? We've got a 13 and a negative 6, but we've got this other thing that don't look like it. That negative 3x looks different. So we're going to go 13 and negative 6 combined to give me a 7. And that negative 3x stays by itself. All right. That's step 2. I probably should put the letters next to it. That'd be pretty cool, right? So look, boom, there's the D step. Boom, there's the C step. Guess what we're doing next? Move all the x's to one side and the numbers to the other. Now, it doesn't have to be perfect. I'm not going to make you do left to right. When I was teaching 9th graders, 8th graders, they had to do left to right. But you can do whatever you want to do, whatever looks like it's going to be easiest. I like to get rid of the negative sign. And if I look at this problem, I say, how do I move that 3x to get the negative way? I'm going to be adding 3x to both sides. And then I'm going to do this in a different color. Let's do purple. We haven't done purple yet. Then if I move the 3x over to that side, then I got to move the 23 over to the other side to get the x by itself. That's our goal. So plus 23. Plus 23. All right. So if we do the x's first, we're left with 5x on this side, and they cancel on that side. And then if we do the other, the numbers, they cancel on this side, and we're left with 30. Oh, this is going to be a nice, neat number. Look at that. All right, what's our next step? Oh, I did 2 steps in one. I added and subtracted the whole numbers, and I moved all the x's. Heck yeah. So I'll go ahead and put M and A on that side. I did it all. I skipped a step. I did it all in one step instead of breaking it into 2 different steps. But I did do it in different colors, so maybe I'll like do this so you can see which color it was that did the step. And I'll post these notes too. That way you can go back and look at them or work them with me or whatever you want to do. That's A-okay. I did that one in red. That's pretty cool. All right, last step. Let's look. Multiply or divide the coefficient. What's a coefficient? Well, that's a thing that's touching the variable. There's only one thing touching the variable here, and that's that 5, right? So divided by 5, and we are left with x equals 6. Boom, 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 boom. Not too crazy? Now guess what you get to do on your own for the sake of time? Plug it in and check it. I'm not going to do that for us, but you get to do that on your own to make sure you're right. And if you're taking a test or a final, you better believe I want you to check your work. Why would you not? Nobody takes to the whole time on the test. I've never had a kid take the entire time, but I have had kids miss questions, and that just don't make sense to me because I'm like, why would you turn it in when you could check it? And you check it, and then it doesn't work, and don't get me started. All right, I'll leave you to do B, and we'll start with, this is kind of a tricky one. It's in the middle, right? Because I see a fraction, right? But technically, this isn't a rational equation yet because the fraction doesn't have an x on the bottom. Technically, this is just an x plus 2 multiplied by 1/4. But we are going to get to review some topics that we need for the rational equations, which is the least common denominator, right? So if you've got something on the bottom, that's called the denominator, the top's the numerator, and we're looking for a common one, right? We want to mash them together because if you remember back to a long time ago when you learned fractions and everybody hated fractions, if you have a over let's say C, C plus B over C. There was this cool thing you could do to simplify your problem, which is you could combine the top and leave the bottom the same, right? So it'd be A plus B over C. That's that, like, the adding fractions. It's as simple as we could say. But it's something everybody forgets. Sometimes people make that C plus C. It's like, no. If I have one piece of pizza out of 8 and 2 pieces of pizza out of 8, that's 3 out of 8. We didn't add the 8s together. We only added the tops, right? That's why that happens. You got questions on fractions? We can make another fraction video, but this is not a fraction video. This is an equation video. So here we go. Let's get started. Drawing the line. Told you I wouldn't forget. All right. Now what I'm going to do is try to find this thing called a least common multiple, LCM. Oh, nope, I lied. That's least common denominator, LCD, right? And I want to find the least common denominator that I can make with those two terms on the bottom. So 4 and 3, do they work together? Does 3 turn into 4 or 4 turn into 3? No. So what we're gonna try to do is we are going to find some number that combines those two things together to get the least common multiple. So the multiples of 3 are like 3, 6. Does that work with 4? No. 9, does that work with 4? No. 12 does. So we got a 12 as our least common because 4 times 3 is 12. So what I'm going to do now is I'm just going to multiply the whole thing across by 12 and see what happens. All right? So, boop, boop, 12. And what you do to one side of that red line, you have to do to the other side, right? Sweet. So now what we've got is, here we get to distribute again, just like we did last time. So what we're left with on the top is 12 times x plus 2 minus 12 times x minus 1 equals 24. I was making sure I did the negative sign right, and we did so far. And then the first term is over 4, and the second term is over 3. Holy crap, guess what happens now? That 12 on the top and the 4 on the bottom, you know what 12 over 4 is. 12 over 4 turns into a 3 over 1, or just 3 on the top, right? So we got 3 times x plus 2 minus, and 12 over 3, that makes sense, turns into 4 times x minus 1 equals 24. All right? So now we got to do what we just did in the last problem where we distribute. I'll go a little faster since we've already done this once. 3x plus 6 minus 4x plus 4 equals 24. We've already done this. Now we got to combine like terms. I'm not going to write it out on the side, but you can if you want to. Actually, I am going to do that. Distribute, combine, M, A, M. I said I wasn't going to do it, and I did it anyways. All right, so let's see. 3x plus 6. We're going to combine like terms. So I see a 3x and a 4x that need to get mashed together. If I have 3 cookies and you steal 4 of them, guess what? I'm left with 3 and 4. Negative 1 cookie. If I have 3 x's and you steal 4 x's, I'm left with negative 1x. And 6 plus 4 turns into 10 equals 24. Nothing to combine on that side. Now we're going to move all the x's to the left. Already done. Now we're going to add all the numbers to the right. Let's see. Minus 10. Oh, that's add or subtract. Minus 10. Cancels out there. Math is hard sometimes. Negative 1x equals 14. Okay, now last step, multiply or divide. In this case, we're going to be dividing. Boom, boom, boom. And we are left with x equals negative 14. Not too crazy? All right. Oh, sorry about that. Went too fast. X equals negative 14 if we're working on it. Now guess what you can do? You can go in, you can plug in negative 14, and you can check and make sure that I didn't make any mistakes somewhere. Sometimes I do make mistakes, and I don't like it when that happens. But what you can do is you can run that negative 14 right there. You can plug it in for x, and after you plug it in for x, you'll see whether or not it was right or not. I'm looking at the answers right now. It is, but sometimes I make mistakes. Everybody makes mistakes sometimes, and I do a lot. All right, here we go. Solving a rational equation. Here's where it gets real. So we just learned about the least common denominator. We just learned about solving regular equations, the DCMAM thing, the distribute, combine. But now sometimes you get the x on the bottom. And nobody likes having an x on the bottom because an x on the bottom is kind of like, I could be a 0, and then everything goes to crap because nobody wants to have a 0 on the bottom. So we're going to see what happens whenever you get a x on the bottom. Cool? All right. Here we go. Zoom in real big. All right, so the first thing I'm going to make a note of, every time I see a rational equation, actually, I guess I can put it right here. Every time you ever see a rational equation, I make this little note. Sometimes I do 3 stars, sometimes I do 1. And I say, what can x not be? There's some things, if there's an x on the bottom, then x can't be something, right? Oldest rule in the book is that when you're in like the 2nd grade learning division, the teacher always says, but you can't divide by 0, right? So then we have to look at the denominator and say, is there anything that would make that x 0? Well, if we had a 0 right here instead of an x, that'd be bad, right? And if we had a 0 right here instead of x, that'd be bad, right? But are there any other numbers that make the bottom 0? Not in this case. So what can x not be? X cannot equal 0. That's just a condition that I'm going to keep in my brain. Because when we get to set theory later and start learning about writing answers in sets of numbers, that's going to come into handy because we're going to know that that number cannot be in our solution set. All right. So, but then other than that, we're going to solve it just pretty much the same. So in our back of our brain, we're saying x is not 0, but it could be anything else in the whole world, and we don't care. So let's see. First things first, we're going to find that least common denominator, like we say. What things combine to make all these have the same denominator? Well, 5, 2, and x. Let's just see if it's super simple to combine them all together and get something like 10x. Because 5 times 2 is 10. Add the x in there, you're left with 10x. Let's just see what happens. So we're going to multiply both sides by 10x. There are other ways to do this. If you come and find me in office hours or class, I'll show you a few other tricks to do this. Like sometimes I don't like to do that. I think this is the easiest way, but personally, I like to multiply each thing by 1 so I know that it's okay. So like sometimes I'd be like, okay, well I want to multiply that 2x by 5 over 5, which is technically 1. Don't worry about that. Erase that from your brain. If you want to come and learn in office hours, we can work through that. But right now, let's do this problem. Draw my dotted line. Oh, it's not red this time. That's okay. So what's 10x times 1 over x? We're left with 10x over x. And then we're going to distribute that 10x just like we always do. That distribution is so important. And it's important to know it's only going to the top. It's not going to the bottom. So 10x over 5 plus 30x over 2x. Now, is it okay that we just multiply by 10x willy-nilly? Like, we don't care. Multiply by 10x. If you do it to both sides. If you do it to one side, bad. Can't do it. If you do it to both sides, good. You can do it. All right, here we go. So what happens? We get an x that cancels, turns into 1, not cancels, but we don't write the 1, so sometimes people say cancels. Now we got that 10 over 5. I'm going to go ahead and write this. 10 equals that 10x over 5 turns into 2x over 1, but we're not writing the 1s. And then we got 30 over 2 turns into 15. X over x hangs out, stays the same. Here's a case where we can leave the x's on this side and move the other stuff over. Now, if you want to move the x's to the left every single time because that's what you want to do it. It's all you. But if you don't want to do that and you say, look, the x's are already by themselves, I'm just going to move that 15 over, that's okay too. So what I would do then for my add or subtract step is subtract this 15. So I don't have to move 2 things. Now I only have to move 1 thing. So we're left with negative 5 equals 2x. And then we're going to do our division step, right? So we're going to divide by 2, and we are left with x equals negative 5 over 2, also known as negative 2.5, but we like fractions. Fractions are better. All right? Not too crazy? Not too crazy at all. You could plug that back in and check it. I want you to plug that back in and check it. I'm not going to do it for this video. I'll always do it in class because we have more time, but you know, I don't have that big of a hard drive and I really got to make some videos here. So let's keep going. Oh, here we go. I'm glad I had that note over there because you know what I forgot to do when I got my answer? What I'm going to do with this, I'm so glad that note was there. I was about to move on. I'm going to draw this arrow so I always remember, and you always remember. At the very least, we got to check this. Is negative 5 over 2 the same thing as 0? No. So it's a good solution. Now, if that were saying x equals 0, we'd be like, oh, crap. X can't be 0. So then we'd have no solution. We'll see that later. But that's just a good thing to check every single time. That's why I make that note every time, because I have to check. And as I'm scrolling, I'm like, oh, crap, I forgot to check. Let me go check. Okay. Let's see. Let you do that one on your own. This one's a little bit more complicated of a rational, but I think you can do it on your own because we really want to get to at least one of these. Yep. All All right, here we go. Checking for an inequality or equality. So this type of problem says find all values for x where y1, it's just a subscript that stands for the left equation, equals y2, just a subscript that stands for y equals the right equation. So here we go. Let's try it. We haven't done this before where we like take a whole big thing and plug it in, but let's do this in blue. Technically this is blue, right? So we could just plug it in right there. And if we do this one is red, plug it in right there, right? So if we're going to write this all out real big, wouldn't it be okay for me to say that y1 equals all that crap equals y2, because of what we have at the top, y1 equals y2, equals all this mess on the right. And now if I just ignore the y1 and y2, because these are all equal to each other, guess what I'm left with? The equation I can use. I can just say those two long things equal each other because they're set equal to each other. And then we're just going to solve it, just like we've been solving all these other problems. All right, set them equal to one another. This is a good example because we're going to get to do a reverse factor, a reverse FOIL, or reverse box, or I don't know how you like to factor stuff, but we're going to have to find the factors of the bottom right term. So let's look at this. We're looking for a common denominator. Holy moly, I don't want to even try to mess with the common denominator. So what I'm going to do first is I'm going to reverse factor, reverse FOIL, look for any types of numbers. Sometimes you use the quadratic formula. That's not very fun, but we got to do it. But this one works out nice and easy. I'm going to look at this bottom right, and I'm going to rewrite it, and you've seen this before. I'm going to rewrite it as a couple parenthesis sets. I'm going to say, well, that first term, the very first term, I know what makes x squared, right? X and x make x squared, right? And then looking at the last term, I know what makes 12. What two things can we multiply to get 12, right? Well, we can multiply 1 and 12, 2 and 6, 4 and 3, and that's it. So which one of those is going to help us to get that 4 in the middle? Probably that 2 and that 6. So I'm going to write a 2 and a 6. And then our brains ask themselves, okay, what signs then? What two signs could get us a, this might not factor. I was thinking this was going to factor. Nice and neat. Super easy. Oh, it is. What two signs get us a negative 12 at the end? A negative and a positive, right? Well, we got to decide where do we want to put the negative or the positive. Do we want to put it on the 2 or the 6? We got a positive 4, so let's just guess. Let's guess and put it with a 6, and then the negative sign with the 2. Does 6 times negative 2 give us negative 12? Yes, good to go. Does 6 minus 2 give us 4 in the middle? Yes, it does. Good to go. All right. Oh, and look at the other side. Doesn't that make a lot of sense? 3 plus 1 over x plus 6, x minus 2. So we got ourselves a little common denominator, don't we? This looks messy and long, but the common denominator in this problem is what's on the bottom right, right? Because if we multiply together the two terms on the bottom left, we're going to get what's on the bottom right. So you might not know this right now, but with enough practice and enough research and going and finding other problems like this, switching out the big long thing for just a, or switching out the big long thing for just 2, you could kind of explore and try to see how this works out. But if you trust me, then we're just going to multiply by our common denominator on both sides. And as we do that, we are going to ask ourselves that same question that we asked earlier, which was, is there anything the bottom can't be? Is there anything that makes us divide by 0? Well, now that I'm looking at this new thing that I wrote, I just zoomed in real big to it. I see two obvious things that it can't be, right? That x better not be 2. I'm going to put it in little blue. 2. And that x better not be negative 6. If that x is 2, we got a 0 on the bottom, and we can't do any more work because that problem's crazy. And if that x is negative 6, then we can't do any more work. So I'm going to make a little note. X cannot equal 2, and x cannot equal negative 6. Cool? Just a little note. That's what I said. I like to put it as a note up at the top just because. All right, well, let's keep working then. Sorry, a little side note. I should have done that at the beginning. All right, so if we keep working, we're going to distribute again, just like we always do. So we're left with 3 times x minus 2 times x plus 6 over x plus 6. And guess what happens? Something cancels. Boom. Makes our lives easier. We're going to do it again. Keep that distribution going. Someone will be sad in the back of the class if we didn't give them a cookie. So we're left with 1 times x minus 2 times x plus 6 all over x. Guess what happens again? Something cancels. So now we're left with 3x minus 2 plus x plus 6. Oh, the bottom's canceled. We don't even have to do any bottom work. That's awesome. Equals, and if we, oh my goodness, look at what's going to happen on that side. 4 times x minus 2. Maybe that's why we picked those numbers. That's why we picked that common denominator. Because look at what happens. As long as we can remember that those x's on the bottom better not be 2 and negative 6, we're allowed to cancel those out. But you have to remember that. So now we're left with, let's do this distribution. 3x minus 6 plus x plus 6 equals 4. All right, back to our DCMAM. That was the distribution. I know I forget to write it every time. That was our distribution. Let's do our combine like term step, where we get what terms look alike, same variable, same exponent. So that I'm going to draw a little line. I'm going to purple squiggle. Anything else look like that purple squiggle? Right there. Green dots. Anything else look like that green dots? Right there, green dots. All right. So now we mash up the like terms, and we're left with 4x, negative 6 and positive 6 cancel out, equals 4. Wow, this is working out super nice and neat, isn't it? This is crazy. So we're left with x. Oh, I'm not going to skip. I'm going to do the work. Divided by 4, divided by 4. So we're left with x equals 1. That's wild, isn't it? Make sure I'm right, because I do not want to post something and then lead everybody astray. So let's see. Boom. Heck yeah. You're going to plug it back in and check it. I'm looking at the answers to save us a little bit of time. All right, so you could probably do be by yourself now. All right, before we move on, I know somebody's going to have some trouble with these ones, but I really want you to get a chance to explore, to try it on your own, to use the strategies. All the strategies you need are in this video so far, and I know I skipped example 5, but that's because that's like a challenge step. It's like you can do it with everything we've learned so far. Cool? All right. Moving on to a couple definitions, and then we'll be done pretty much. We'll be pretty much done after these definitions. So we've got 3 types of three types of equations that we'll really see in this class. All right? We've got an identity equation. An identity equation has a really cool solution. This is probably my favorite thing in the world. Identity equations where you do all this work. We just did all the work in the world, and then what we end up getting at the end of the day is the same thing on both sides, or they cancel out. So like, let's say we do all our work in the whole world, and then after all the work, it ends up being 2 equals 2, or 1 equals 1, or x plus 2 equals x plus 2, or x equals x. That's what I'm going to write. X equals x. Question mark? That seems weird. If I start dividing the x's, they just cancel out and turn into 1 equals 1. What does that mean? Well, that's the identity. That means that x does equal x. 1 does equal 1. 2 does equal 2. That's like a tautology in math. That's the truth. This is true all the time. So if we're looking at that identity, it's got a cool answer where you draw this little squiggly bracket line, which we're going to practice a lot in the next few videos. And we're going to write x, draw this line, this straight up and down line, and we're going to write x is a real number. Or sometimes you don't have to. You can. We can talk about what this all means. Sometimes people will be like this. Those weird symbols where that just says x is an element in the reals, or the real numbers, a set of the real numbers, which is pretty cool. But they'll still write the x, they'll still write the brackets and the x and the line. They'll just put that on the right side of it. All right, then a conditional equation. Conditional equation is the most common one, even though I think identity is the coolest because it's like it's the truth. It's the governing truth of the universe, that if something is something, then that thing is that thing. It's like you can't get away from it. Conditional equation says, okay, well, this is true for at least one number, right? This is true in at least one situation. So the classic equation of like 2x equals 4, we could all solve that in 2 seconds. X equals 2, right? That's a great example of conditional equation, because if 2x equals 4 when x equals 2, that means there's at least one place where that's true, right? So the solution set then literally would just be 2, which is crazy. It's like that is the answer to that thing. Now, if I had a square root and then a plus or minus, then it might have 2 answers, or there could be some things with 17 answers, but that's a conditional equation. That equation is not always true. It's only true when in that set. And then we got an inconsistent equation. Inconsistent equation is the opposite of cool. It's bad. This is like where we get down all our work and we finished all our work, and then you have something like, I don't know, let's see, 2 equals 3. What? And then sometimes they'll draw this line or they'll do this exclamation point. They'll be like, 2 can't equal 3. That's an inconsistent equation. That means that will never, ever happen, literally ever. Another cool example of that would be like x equals x. What? Plus 1. And you're like, oh, no, I can find an x where x equals x plus 1. It's like, oh, can you? Subtract x from both sides. You're going to be left with 0 equals 1. That's not true. So that's a contradiction or a bad thing. That's bad in math. And we have a set for that as well. Instead of drawing the little brackets and the squiggly sets, we draw a circle and put a line through it. It looks like a, I don't know, Pokeball or a circle with a line through it. And that's called the null set or the empty set or the set of no sets. It's not a set. It is the opposite of a set. It's just no elements, no things in that set. That means there's no possible things that can solve that question. So I'm not going to do all however many of these there are. I'll do one of them, classify it, and then let you solve the rest. And we'll work on them in class together, and we'll discuss what they look like. But we still use those steps. I'm going to do this real nice and neat. Are you ready for this? D stands for distribute. Boom. Distribute that 2. We're left with 2x plus 2 equals 2x plus 3. Cool. Next step. C, combine like terms. Well, I see the blue squiggly line. Anything look like it? Not on the left side, so I got red dots now. And then I've got on this side, I've got a green triangle line. And then I've got a purple, I don't know, what other kinds of lines are there? Hatch line. All right. No like terms on the same side. So we go with M, which is move all of the x's to the left. So subtract 2x, subtract 2x. Oh no, something cool is going to happen. Those cancel, those cancel. We're left with 2 equals 3. Exclamation point, or this little lightning bolt looking arrow sign. Bad, bad, bad. That's a bad version of that. Let's do better. That's bad. So we solved it. We got down to the simplest form. They said 2 equals 3. That's not good. So we're going to go back up to these 3 and say, which one of these is? It's an inconsistent equation. There's no solution. Oh, another way you could write that. Sorry, I should have written that way up here. No, you've heard this before a lot. No solution. There is no solution. Cool. Awesome. And so, long day, I know. Hopefully it's a lot of review. Hopefully it's not too bad. But that is how we solve linear and rational equations. If you have any questions, you can come to office hours. You can ask them in class. We'll explore together. You could ask someone in the class. If you don't understand any of this and you're like, I think I'm in the wrong class, then you really need to come talk to me, and we'll try to work through that and then figure out if there's a different class to put you in, or how we're gonna make it through this year, which we are gonna make it through this year. So that's linears, that's rationals. I'll see you in class soon. Hopefully this helps you. If you're not in my class and you're just watching this to learn linear and rational equations, even better. You're still more than welcome to email me or contact me and let me know if you have questions on something else, or if you want me to make a different video that helps with something like FOIL or box or any math thing. It could be 3rd grade math. You say, hey, I need help with 3rd grade math. I would love to help you with that. So thanks for watching. Have a good day. Can't wait to make some more of these and teach some more math.